Okay, we're going to jump into Unit 1, Lesson 9, and Lesson 10 here, which is going to build off of the what we've been talking about in the past lessons, which is that if we want to have more detail, or if we want to be able to store more information, then we need more bits, right? So more bits is more information, but the problem is that we have a certain amount of storage on our computers, so we can't just store an infinite amount of information. So what we need is we need some strategies to compress that data, to compress that information, to make it smaller so that it's easier to store on our computers and it's easier to send to other computers, right? Because if you've tried to send a large file before, it can take a long time, or if you're trying to upload a large file, it can take a long time. So we need strategies to compress that data to make it smaller so it's easier to store and easier to send. And one of the strategies we can use is called lossless compression. So if we look at the warm-up here, it's got a list of common abbreviations. It's asking what other abbreviations you can add to this list. You can just quickly brainstorm, right? These are things that we use in text messages all the time. The main takeaway I want you to think about, though, is why might we use these abbreviations? What are the advantages to using these abbreviations? So take a second to think about that. You don't need to write anything down right now, just kind of brainstorming in your head. What's the advantage to using the abbreviations? So for some of us, an advantage might be that it's just quicker, right? And when we're sending a text, right, we can type it out a lot quicker if we're using those abbreviations. Okay. Other people, it might be a storage issue, right? You only have a certain amount of storage, right? So you have to use the abbreviations to keep this storage down, the number of characters down, right? If you're sending out a tweet, you only have a finite amount of characters that you can include in that tweet, right? So you have to use abbreviations. And these are all same reasons that a computer would compress something, right? It's to be able to store more information because they've compressed things to send things quicker. It's a lot faster for them, okay? And they have a limited amount of storage, so they have to compress it in order to be able to contain it all. So take a look at this message here. So let's imagine that I wanted to send this message. I don't know why I would want to send this message, but let's imagine that I would want to send this message to one of my friends, right? The problem is that I can only include 80 characters in my message, right? So it's like a tweet, right? I can only send 80 characters. This is more than 80 characters, so I won't be able to send this entire message, right? So I've got to come up with a strategy to condense this, to compress this, to make it smaller. So instead of sending this exact message, right, this pitter patter with the underscores and everything else, I end up sending this message over here on the right. So this message on the right, it's got two parts. Notice that it's got two parts. It's got a key, which is right here at the bottom, which is also sometimes called a dictionary. Okay, so it's got a key, and then it's got the original message, right? Or not the original message, but the compressed message, right? So this message that was on the left, this pitter patter with all the characters in it, was compressed into this message on the right, and it's got these symbols here. Right, so you can pause the video here, take a second, you'll be able to figure out what's going on, right? They're using these symbols to represent parts of the message, right? And then they're just filling it in there so that it's like a code. Okay, take a second, look through the key, see if you can identify how they're compressing this message, right? And if you could reconstruct the original message using the key if you had to. So you can pause the video, take a look at it. So you can think about this. You don't need to write anything down again yet. This is just says, how is the message the same as the first? And what actually gets sent to my friend here? Okay, so we can see that there are parts that are exactly the same as the original message, right? There are some words that are exactly the same as the original message. And then there's some parts that are obviously different, right? There's these characters that don't show up in the original message. And what actually gets sent to my friend is two pieces, right? It's the encoded message, or the compressed message, I should say, the compressed message, and it's also the key. Both of those have to be sent. If they aren't both sent, then my friend won't be able to reconstruct the original message if they don't have the key, right? So they need the key, so they need both pieces. And so then it only makes sense to do this, to compress using this strategy, if the combination of the compressed image and the key is less characters than the original message. So I'll say that one more time. It only makes sense to compress using this strategy, which is a lossless compression strategy. We'll look at a definition in a second. It only makes sense to do this if the compressed image plus the key is less characters than the original message, right? So we have to consider that as we compress things and send messages using this compression. So you can jot this down here. We'll call this lossless compression. You can title this at the top, lossless compression. Let me go ahead and write it so you have it here. So lossless compression, you can write it has two parts. You have the message and you have the key, which is also called the dictionary. And both of those parts must be sent and stored. So go ahead and jot that down there. Right below that, you can go ahead and define what compression is exactly. It says compression using abbreviations or symbols to represent a message in hopes of representing the same information with fewer characters. So the goal is that you're going to represent the same information with fewer characters. And so then you can see from this example that I just gave you here, the original message was 93 characters. That original pitter-patter, right, the whole thing was 93 characters. And the compressed message plus the key, right, so the two parts, the compressed message plus the key, was 56 characters. So in this case, it would make sense to compress the message using the lossless compression strategy that I just went through. So you're going to go ahead and go through this activity here on your code.org. So you can head over to code.org and go through the first bubble there. It's got a text compression widget. Okay, so it says go to level 1 on lesson 9 and go ahead and play around with it there. You can take note of a couple different things. Down here at the bottom, it tells you exactly how many bytes you're using. So how many bytes you have in the original message. And then as you start to create your dictionary, which is on the right side, which is your key, right? As you start to create your dictionary, it'll show you what your compressed message is and what kind of a compression ratio or compression percentage you have, right? So you see how much you can compress these messages. So you can play around with that, right? See what kind of a score you can get, what kind of compression percentage you can get. And then we'll come back together in a second. Go ahead and pause the video and go ahead and work on that for a few minutes. This is lesson 9, level 1. All right, so as you go through that, hopefully you're starting to get the hang of it. If not, you can always ask a neighbor, but I want to go ahead and highlight a couple of times again, right, that we have down here your compression rating, which is in that bottom box here, right, and you can kind of see how they're doing this on the right side. So that sun character is the equivalent of didn't know I was lost, right? So everywhere that showed up, okay, you can see it's being replaced by the sun character, and you're trying to do that as efficiently as possible. Okay, so you can continue to mess around with that, see how well you can do. And then there's a video for you. You can go ahead and watch that video. It'll explain the widget even further, but it'll also talk about the different types of compression and how they're used in the real world. So you can pause the video, take a look at that video on Bubble 2 on your lesson 9 there. Okay, so after watching the video, hopefully you've got a clear picture of what we're doing there with the widget. So what are some strategies you're using to compress your sample? Which ones seems most useful? You can think about that in your head here. Okay, so I'll give you a second to think about that. You can pause the video, kind of brainstorm there. So some of the strategies you might be using there are looking for repetition, right? That's the biggest one, is that you're looking for things that are repeated over and over and over again. That way you can come up with a symbol, okay, a key for in the dictionary, okay, and then you can just replace that repetition with one single character, and then it'll compress your data, right? Another strategy that you might want to use is using characters embedded in other characters. So let me tell you what I mean. I'm going to flip back all the way to the original message that I had here, because they did this in their original dictionary and their original key here. So notice that first they said that this umbrella was going to represent this TTER combination. And then the snowman was going to represent PI plus the umbrella, right? So they're using the characters embedded within other characters. Okay, if you get down here to the star, now the star represents the snowman and this little comet or whatever that is, right? And another snowman. Okay, so you can see that it's got the characters represent are embedded within other characters to compress it even further, right? So you can go ahead and try that on yours. You can go back to your compression widget and continue to mess around with that. See what kind of a compression rating you're getting there. And then you can scroll through the drop-down menu and you can explore other texts. So, you can look at ones that you think would be easy to compress. You can try a couple that would be difficult to compress. But go ahead and pause the video, spend a few minutes there. Okay, the next slide says that we're going to go ahead and pick an easy one and pick a difficult one. You can just pick a couple different ones and play around with it, just so it's something that will stick in your brain. The experience of trying to compress these the best that you can. Okay, just spend a couple minutes, 5 minutes or so, going through those, trying to get the highest compression rating that you can. And when you feel like you've got a good grasp on it, you can come back to the video here. All right, so let's go through the wrap up here. Hopefully you had enough time to scroll through the different lyrics that are there, the different messages that are there, and try to compress each one, and you can see which ones are difficult, which ones are easy. So what made some messages easier to compress than others? So you can jot this down in your journal now, right? It's easier to compress these images when there's a lot of repetition. Okay, if there's not a lot of repetition, then they're more difficult to compress. Right? They're also going to be easier to compress when there's smaller messages, right? Because there's less things to compress to start with. And then make sure you get this definition down in your journals. This is the definition for lossless compression, because we're going to look at another compression strategy in the next lesson here. So it's going to be very important that you know the difference between them. So lossless compression is a process for reducing the number of bits needed to represent something without losing any information. This process is reversible. So that is crucially important. Please make sure you underline this part down here, right? So we're reducing the number of bits that we need because we're reducing the number of characters, right? So there's less information there, but we can reverse this, right? We could come back to the original message using the key. You could reconstruct the original message that you had, right? So things are not lost permanently. Things can be restored to their original version. That's very important for the lossless compression. Things can be reversed to the original message that you had there. All right, so when you're ready to move on here, you can go ahead and continue to watch the video here. If you need to pause it to jot this down, go ahead and do that. We're going to move to lesson 10 here, which is on lossy compression. So you can turn to a new page in your journal. You can title this one Lossy Compression. So, if I was in person here, we'd be able to see this app in action here. It actually is like a little movie here. It scrolls through here, but you can get the general idea of what's happening here with this lossy text compression. So we've got our original message up here at the top, and then our compressed image down here, or our compressed message down at the bottom. Notice there is no key here, right? So there is no key for this one. Okay, so we've got the original here, we've got the compressed here. So some similarities and differences between what we were doing in the last lesson with the lossless compression and what's happening here. Can you go ahead and take a second to think about that? And then when you're ready, you can unpause the video and we'll talk about it. So hopefully you're thinking about, well, a similarity is that the message is becoming shorter. So just like before, right, we're getting less characters. So we started with this, right? There's less characters in the compressed message down below. Okay? But one of the major differences is there's no key, and we're actually just throwing pieces out from the original message, right? So they're just disappearing, they're going away, right? And that's it. They're just gone. So the message is shorter, but there are pieces that are just missing. Okay, and if you just had this original message, you might be able to figure out what it originally said, but there's no way to reconstruct it exactly because there is no key in this type of compression here. So can you navigate to Code Studio and go to, now you should be on Lesson 10, Level 1. And on Lesson 10, Level 1, you'll see that there's a little widget there. Okay, and we're going to look at lossy compression. So they sound very similar. We got to know the difference, right? Last lesson was lossless compression. Lossless, like we're not losing anything, right? Because we have the key so we can reconstruct it. Now we're going to look at lossy compression. You can think of this one as things we are going to just permanently delete some stuff to make it smaller, to make it more manageable, right? And you saw that in the video that you watched in the last lesson, that things are just going to go away for good, right? Most of the time, we won't even notice they're gone because they're not we can't see it with the human eye, right, or with our ears, right? We wouldn't be able to know that pieces of the music were gone, right, because it's so small. Okay, but things are permanently gone, so they can't be restored to the original version. So you can look at the original number of bytes required down here, and then the compressed number of bytes there. As you go ahead and play around with the widget there, it says, what do you notice about the quality of the image when you compress it? What do you notice about the size of the compressed file size? So take about 30 seconds. You can go ahead and play with that image of the bus there. Okay. Remember, you've got to hit run on the app there to make it work. Okay, hopefully you had a second to play around with that widget there, right? You can see that as you compress it, the number of bytes decreases from the original. Okay, but also as you compress it, okay, the quality of the image is getting worse and worse and worse, right? So the more compressed it is, the less bytes it requires. But again, because it's less bytes, less bits, we're going to have less detail, so the image becomes a poor quality. You can go to level 2 now on code.org, so you can slide over there in a second, right? And it's going to ask you to upload an image of your choosing. So you can go to Google, right? Find an image, school appropriate image of your choosing. Okay, you can find the URL for that image, and then you just click on where it says new image, and you upload it there. And then you can play around with the slider there, right? So you're going to compress that image and get to a point where you think it's, you can still tell what the image is, but you've compressed it a little bit so it's not taking up quite as many bytes and quite as much storage, right? And there's this weird balance where you want to get rid of as much extra information or as many extra bits as you can, but you still want to preserve some sort of quality in your image, right? So go ahead and see if you can find where that line is with the image that you're using. I'll give you a few minutes there. You can pause the video. If you'd like to, you can share with a friend, right, what you've done. You don't necessarily have to do that. I'm not in the classroom here, so you can go ahead and do that if you'd like to. If you want, you could compress it way down, right, make it super blurry, and then show it to a neighbor, see if they can figure out what it is, right, and then see how much you've got to slide it back to the original before they can figure out what it is. Those games when you were little where you'd be like super zoomed in on an object, you try to figure out what it was. That's what we'd do if I was there, right? I don't want to overwhelm the sub though, so you can do it if you'd like to. If not, we'll move on to the next part. So there are going to be some instances where this lossy compression is okay, right? Where we are willing to sacrifice quality of the photo because it's not going to make a major difference. And then there are some instances where we're not going to want to do that, right? We need the quality to be pristine. We need 100% quality, right? So we'll go through a couple of different scenarios here, right? And you can kind of brainstorm whether or not this lossy compression would be appropriate and how much compression would be appropriate. So we're going to use the same photo for each one. So as I scroll through these, you can just kind of think in your head what would be appropriate, right? So it says we're trying to use this image for a particular purpose, and we need to decide how much lossy compression we want to use. You've got 4 options. You can do 1, which is no compression, right? You've got the original option, or all the way down to 4, right? And you can take a look at 4 here. I'll zoom it in for you, right? Pretty poor quality there. So there are a lot of compression is happening there, right? You're getting rid of a lot of detail. You're throwing a lot of stuff out there, right? And so then the quality goes down, okay? But obviously the number of bits required improves. Right, so from 1 to 4, 1 is that there's no compression. The original image, 4, a lot of compression, fairly poor quality. Oh, we didn't go through the scenario. Scenario 1, you're sending this as a text message to a friend, but you've almost run out of data on your phone, right? So you got to consider, okay, well, you're sending this. Would you want to send this with no compression, or is it okay to lose some of the quality? That way you can fit it on your phone, right? So in this case, probably something along the lines of, 3. I don't know, if you really wanted them to see, you really didn't care about the detail, you could compress it a bunch and then send it so that it fits on your phone. Okay, obviously, it depends on some of the details in this scenario, but the general idea is that if you're just sending this as a picture to your friend, it's probably okay if you compress it and lose a little bit of the quality. That way you can store it on your phone because your phone doesn't have much storage or data. The next scenario is that you're at a crime scene. You're a crime scene photographer, and this image is part of a crime scene photo, right? So take a second to think about what would be best for this scenario. I'll give you a minute to think about it. So probably in this scenario, something closer to 1 or 2, right, where there isn't much compression happening is going to be pretty important, because if you're at a crime scene, you're going to really want all those details there, right? If you start to give these really blurry photos and you're at a crime scene and lose all the pictures of people's faces and stuff, probably not going to be good. So in this scenario, probably you wouldn't want much lossy compression. Let's go to scenario 3. This image is part of a satellite imaging assignment for the military being used for intelligence gathering. So think about that there. So similar to the last one, right? If you're using this for the military for intelligence gathering, you're probably going to want the details there. So no compression or small amount of compression are probably the correct choices there. We'll keep going. You're a social media manager posting this to an Instagram story for an event happening right now. Okay, so if you're trying to promote this on Instagram, right, then you probably want it to look good. So you don't want to just post up a blurry photo there. So you probably don't want to go down to large amount of compression, right? So you probably want to stay closer to no compression again or small amount of compression again. All right, we'll go to the next one. This image will be part of a collage where 100 copies will be stitched together to make a larger image. You've seen those things where you've got these like bunch of tiny little miniature photos, and then when you zoom out, you can see like an even bigger photo that they've created. So in this case, since it's going to be 100 of these little miniature photos, right? It probably, you probably don't need all the details because it's part of a larger photo itself. So you can probably go with a large amount of lossy compression, right? So that the quality is not there, okay? But since you're going to have so many photos, you probably want to compress it down pretty good. And then scenario 6, you're a professional photographer submitting to a design competition. So if you're a professional photographer, you probably don't want to have any compression if you're submitting this thing, right? You want to keep this so that it's looking good, okay, nice and clear, so no lossy compression there. All right, let's go to the wrap up here. So you can think about this here. In fact, why don't you write these down in your journal so we can talk about them right now. So when is it a good idea to use lossless compression? When should you use lossy compression? And what are the important factors in making that decision? Can you go ahead and jot down those prompts in your journal? You can pause this and then see if you can answer this to the best of your ability right now. And then we'll kind of talk through this over the next couple of slides. So for lossy compression is useful when the file size is a concern or when it needs to be sent in a reasonable amount of time, right? And the important part for lossy compression is that we don't mind or we don't need to reconstruct the original message, right? We can get rid of some of the pieces and we're not going to notice the difference, right? That's when it would be okay to use lossy compression. Like the human eye is not going to notice if you take away a little bit of the quality of some photo, right? Or some of the minute details of an audio file, right? And then lossless compression is useful when the accuracy of the original item is most important. So lossless compression is important when we need the exact message, right? So if we had like bank records or something like that, we wouldn't want to just throw out pieces of that because, you know, we need to have all the details there, right? Or if you're at a crime scene investigation, okay, we need to be able to reconstruct that image exactly as it was, right? Or that message exactly as it was so that we can see all the details. So if we need all the details, that's going to be best for lossless compression. We need to be able to reconstruct it. And here's the formal definition for lossy compression, right? We've gone through this now, but just so you have it down, I'll give you a second to copy it down. So it reduces the number of bits needed to represent something. Some of the information is lost or thrown away. The process is not reversible. So once we throw it away, it's gone with lossy. Okay, we won't be able to restore exactly what we had. Okay, that's it for these two lessons here. Hopefully you're able to identify the difference between lossless and lossy compression. Of course, feel free to reach out if you've got any questions and use your neighbors for help if you've got any questions as well. All right, thanks for watching.